So finally, okay. Hello everyone, and well, as I post on the Slack channel previously, and today we're going to start with a Docker workshop, and well, we will be present. Me and Martin will be presenting, and so let's talk first, like a brief intro, what the workshop will be about. Um, well, the workshop will be consist of 3 series, so it will be like from now on the next three. Well, today and the next two backend meetings, we present the workshop, and basically it consists on to show what Docker really is and how useful it is for development and for deployment. So it will be divided in today. We're presenting the Docker basics, and next Tuesday, Docker for development, and then we're going to present Docker for deployment. So pretty basic how it's divided. So let's jump into the first one, Docker basics. So the agenda for today. First, we're going to talk about, like, I think to show a basic about Docker, we first need to start like with some concepts. And I think that the concept should be like virtual machines and containerization, because that's basically the backbone of all of this. Then we will jump on what's Docker, show about show how the Docker architecture is divided, and it consists of like Docker daemon, Docker client, Docker images and containers, and then Docker registries. And then we're going to stop with the theoretical part and start with some examples, like some like real life demos. We show hello world in Docker. Then we're going to talk about like how to build images in Docker. And finally, and I think the most interesting part will be Dockerfile, which is used like everywhere when you want to start using Docker. So okay, let's start with containerization versus virtual machines. So the first thing is to tell like both are virtualization strategies. Of course, they differ in some aspect that we were going to see that in a moment. And basically both tackles the same, like, let's say, principle that there are self-contained units that could run everywhere, right? And they share the same goal, which is like isolate application and all it depends in. Let's say you have this unit that could be like either a virtual machine or a container, virtualized container, and you can put it in any hardware with proper like libraries, and it should run. Just like think of like a Java virtual machine, but this is more like deploying stuff, not like running stuff. So the first part is virtual machine. So basically, virtual machine they focus on like virtualizing the hardware. So the virtual machine is consists of some like a, well, in this diagram we have like the hypervisor. It could be like anything else, but the idea is like this layer is like virtualizing the hardware to other, let's say, guest operating systems. So the operating system will never know like, oh, I'm running on top of a virtualized environment or on bare metal. So that's the idea of the virtual machines. So, well, on top of this, any like virtual machine, you can see like application A, B, C. They run every program like a real computer, and they contain its own, let's say, virtualized operating system, CPU, network, input, output, and storage. And of course, it runs on physical machine. Everything that's virtualized should run on some physical machine. And this, like I mentioned before, there's this layer that could be either like on top of the host machine or bare metal. In this specific diagram, you can see that you have infrastructure, which is it's basically hardware, and then he's the hypervisor. In this diagram specifically, the hypervisor is like the operating system of the whole virtualized environment. But it could happen like between hypervisor and infrastructure, we have another host, let's say like another operating system, which is basically hosting the hypervisor that will virtualize everything else. But then we have the different like virtualization strategy, which is the containers, which in this scenario, we're not going to virtualize the hardware, but we're going to virtualize the operating system. That's basically the major change between both strategies. And you can think of like it's a sandbox for a process. So the thing is like the process that is running on this virtualized environment is tightly coupled to the container lifecycle. So imagine that the container exists only when the process is running. Once the process is like finished, the container will like stop executing. It's not like virtual machine that you can just run a virtual machine and it will just like run as a normal operating system. In this scenario, is basically you're basically imagining of a node application. The container will live until the application is like running, and if for some reason it crashes, the container will die basically and needs to be replaced. And as you can see in the diagram, in the container strategy, each container shares the host system kernel. So instead of having like replicating the operating system, we just replicate the libraries and utilities that the application needs, but the kernel is the same, and in most cases it's Linux. Okay. And of course, these containers run on top of some runtime that in the diagram is representative of the container manager, which is after the host operating system. And it could be like it's basically this layer that is responsible for like spawning and destroying and replacing all the containers. And of course, there are many like let's say like implementation of this. The most famous one is Docker, of course, but there's many others. And since we utilize the kernels, the kernel host, the operating system kernels is lightweight compared to virtual machines, and of course, boot quicker than virtual machines.
Mm-hmm. Yeah, so basically, containers are a better choice when your like biggest priority is to maximizing the number of running applications on minimal number of servers. That's probably.
Yeah. Do you have any
case of it when you use or when you choose the containers against the virtual machines? If you want something more like configurable and more like robust, then probably the virtual machines are your choice. So
yeah, exactly. And do you have any question of the previous section? We're going to like have a briefly break because it's very theoretical and could be very heavy to process.
Yeah, I just remember when I installed like Docker on Windows, it actually like used the virtual machine.
Yeah, that's the thing. Well, so as I mentioned before, this technology, the container strategy could be. I mean, there are many solutions. The most famous one is Docker. Particularly Docker, it runs like natively on Linux. So that's why on Mac and Windows, there's some like on the latest version, there's something called, you install something called the Docker Desktop. That behind the scenes is like a virtualized environment of Linux. Because you cannot like natively run, I mean, never could you can run on Mac on Windows. So that's basically, it's like it's like using a virtual machine of Linux, and then on top of this virtual machine, there's the Docker environment. That's what is happening behind the scenes.
On Windows.
And Mac as well.
Okay.
And any other question? No? Okay, so let's jump on what's Docker. So basically, well, it's implementation of this strategy that I just mentioned, the containers. And one of the core characteristic is like it uses a layer file system, which is called union file system. Probably if you're kind of like familiar with Docker, you have heard of like the Docker images contain of layers that could be cached. So basically, this is a union file system like behind the scenes. And Docker allows you to declare like a plug and play volumes and network units. So basically, you can imagine of a Docker container as a Lego piece, which is Lego like toy, and then you can put volumes if you want and replicate the volumes, or put or move this container and put on another network, and the possibilities are like infinite, I would say. And you have something called registries, because once you have this like we're going to talk that later, but this basically a place or a repository of where you can push or pull your images to from. Yeah, basically that.
For reusing it.
Yeah, exactly, for using. And Docker comes with two versions, two editions, Community and Enterprise. Community is the free one, which basically all of us use. And Enterprise is the community plus some like dashboard, the graphic dashboard you can put, I don't know, put some easy stuff. But at the end, the community edition is enough. And one cool thing about Docker, and we're going to see on the third session of this workshop, is like it comes integrated with an orchestrator or cluster manager, because it's cool to have these Lego pieces, but there should be a way to integrate them together in the same network, layer. And not only that, but on multiple hosts. So at the end, you will have like a cluster managed by Docker. So why do developers love Docker? Basically because it's less overhead for the application, because they are rapidly deployed, patch, and scale. And the portability, as I mentioned before, is you can think of like basically an analogy of Java virtual machine. Well, this is basically for like how to encapsulate application and running everywhere, no matter what the architecture. And basically, of course, it provides like consistent operation of the environment. I mean, like for example, when you have your Docker, you can see like as a process, the Docker container have a life cycle that you can basically is like well implemented and well managed by the ecosystem. So you can replace, you can update, you can like push on and pull the images. You will see it later. And this is one important thing, which is the isolation, because since you have the same kernel, but the utilities are different per container. You can think of like the same code, but then you have like a container of Node version 8, then you have another container of Node version 10, and both are running the same code in the same host machine without colliding each other. So the isolation, that's kind of like a sample of the isolation, and also the security, because each container could be run on different networks controlled by the Docker ecosystem. Do you want to add something?
Probably not. You mentioned everything.
Okay. Any question? Okay.
So you said like the difference between virtual machines and containers and Docker is that like you don't replicate the operating system. Like in virtual machines, like
whole the operating system with all the configurations and stuff around.
But like,
and, in Docker, you are not replicating the kernel, but you are replicating just some like system utilities.
so if I select this distribution of Linux, like DAEMON or whatever.
Yeah, they probably have some. They are using your host computer's kernel. If you are on Linux. If you are not on Linux, then there is like virtual machine with the host computer, and it's using its kernel together. So that basically this fact makes it like more lightweight than the virtual machine.
Yeah, for example, the booting of the kernel and stuff that could take like, I don't know, it depends of the operating system, of course, but it could take like 1 minute if you avoid that part, because the operating system already boot. What is booting is the container which all its libraries, let's say, it has Node installed, so that's kind of like, Node needs to, I don't know, run and stuff. So that's basically one of the key difference. So, okay. So this section will be about like the...
Do you have any other questions? Feel free to ask. It's interesting. No?
Okay.
When someone asks a question, can one of you repeat it so everyone will hear the question?
Yeah, sure.
Including the record.
Oh, okay, cool. Okay, so, this section is Docker architecture. So, the architecture of Docker is basically consists on a client-server architecture. So basically we have the Docker client, and then the Docker client communicates to the server, which is basically what is managing everything, like containers and everything else. This is kind of like basically one diagram that can show that. I will explain later. So the first thing is the Docker client, is the CLI, is the first thing that you can like interact with through your terminal. And it basically, you can see it contains many like many commands available, like docker build, pull, run. Everything has a different like different purpose, of course. But in this diagram in particular, it's very interesting because you can see that the bots of client is different from the Docker host. This is one of like one scenario, but mostly when you're installing Docker, the host and the client are the same computer. But this could happen, like for example, the client is my computer, but I want to communicate on some like a remote cloud. So the host of Docker is somewhere else, right? Then we have the Docker REST API. Docker, the server is basically a REST API, so the CLI is behind the scenes is just calling some REST endpoint. And then we have the server itself, which is a daemon. So basically a persistent process that is listening to events, and when the events comes, it basically performs some action, right?
It's a Linux socket, I believe.
Yeah,
it's like a both-way communication.
Yeah, exactly. The easiest way to communicate, the fastest, is through unit socket. That's the default way.
You can send requests to it, but it can also produce events for you.
And then we have the last like portion, which is not represented here, but it's called Docker machine, which is like basically a Docker client, but will like multi-host like capabilities. Basically, it's like you can set like different SSH like credentials, and they communicate to multiple hosts from a single machine. So let's talk more deep about Docker daemon. Basically, it's called dockerd. And yeah, as I mentioned before, it's a persistent process that manages like the images, the containers, networks, and volumes. That's basically on high level what the daemon does. Then we have the Docker client, which is the default way to interact with Docker daemon. And you can use commands like docker run. We'll explain what everything, all of those, what is the purpose of all these commands. And it follows a client-server paradigm. And as I mentioned before, it can be used on different hosts where the daemon is located. So yeah, you have your AWS cluster, and your client is locally here, and you can communicate. And so some of the most used commands of Docker are shown here, and you will see like most of the commands of the Docker client are focused on either on a container or an image, never to both. Like for example, the first one is pretty basic. It lists Docker PS, lists all the process, all the containers that are currently running.
You can show it maybe in terminal.
Yeah.
Just to have some hands-on lab.
Yes. So basically, yeah. So for example, this Docker PS, as you can see, it is like a table. I don't have any container running right now, but for example, docker run, if we could help, it runs only on an image. Like you have to have like an image, and then it will run some command on top of that image. It will create a container. But that other like all runs on containers. For example, docker exec. That's one example, and yeah, we will see later. For example, the last two, docker rm is to delete a container, and then doc rmi is to delete an image. We will see that later. So what's the difference between images and containers? Because that could be confused. But I think since all of us are software developers, I would see basically as if an image is a class, container is basically the instance of this class. That's basically it. So basically that image is a read-only blueprint, and a container is an instance of that image. That's basically the simplest way to understand this. And one thing is like containers come with a writable layer that you can update. Of course, you can have a container, write something on it. Like create the simplest way is create a simple file, and then you can commit this change. And by committing it, you will create a new image. But we will see that this is not the most efficient way to create a new image. We will see that the best practice to create a new image is through Dockerfile, not to committing a new change to the container. We will show that later. And I don't know if you remember that previously I talked about registry, which is like a repository. Well, Docker registry is one of the, let's say, I would consider like part of the architecture of all of this. And basically, Docker images can be pushed to or pulled from registries. Every Docker registry contains repositories, and every repository match like a single Docker image namespace. So imagine that you have your backend API ready to be deployed as Docker container, also a Docker image, and then you create this namespace which represent this exact API. But the thing is, like after that, you have tags that provide versioning to this image. So you can have like a development, a version, a staging, production, or you can just name it like version 1, version 2, version 2.5, and whatever you want. And the registry could be public and private. The most, by default, when you're playing with Docker, you're pulling images from Docker Hub, which is the default public registry, which is complete free. And well, recently, where is it? Here. What is like dark? Well, whatever.
What are you looking for?
Yeah, no, but the thing is, like, this is we just recently created a new, let's say, a user for Docker Hub for STRV. Right now we have like 2 images, but it's great to like push our public stuff there. Where is the presentation? Just closed. Okay, it's here. My God. Okay, sorry for that. Oh yeah. And of course, you can have with Docker Hub is for public stuff mostly. You can have like a paid private namespace, but there are other private services such as, well, Docker Hub. You have Elastic Container Registry for AWS. You have Cloud Registry in Google Cloud, and Azure also provides some like private registry. So yeah,
Let's code something.
Yeah, let's stop talking and
Okay, we'll try to code something. Okay, so we found some.
Yeah, let's.
Sorry. Good. I know. We found some good sample on the internet. It's like self-explain sample, and it's a hello world.
It's
but
not shown.
It's not showing all the thing. Okay.
Oh.
How can I? Oh, it doesn't fit to the screen. Maybe we can get this window smaller.
Can you clean the terminal? And you should go on top because it has all the.
What?
Oh well. That's cool.
Okay. It's. Yeah. So as you can see, this is like really self-explaining and very like, not very like educating. So it tells you everything.
It's wrong and it's also small.
Yes.
Yeah, I don't know why it gets dark.
So now
It's not right of the.
Very
Maybe
good.
because of the presentation.
No, I get it smaller.
When the presentation is on full screen, it's automatically like reuses the brightness.
Yeah, can you?
What should I do?
Okay, cool. It's better, right?
Perfect. I will not rather touch it. Okay. So as you can see, this hello world sample is written in C, and Docker managed for you that program written in C can easily run on your whatever computer or operating system you have, and even if you don't have like compiler for the C and stuff. So, as I said, it's self-explaining. So what it did is written exactly here. The Docker, when I typed docker run hello world, the Docker is the CLI utility. It sent a message, a JSON message, or to the Docker daemon. So Docker client contacted the Docker daemon. DAEMON checked out if the hello world image is already present on the machine, on the computer. It probably
It was.
wasn't.
You can see, yeah, at the beginning,
was.
the first line it says unable to find image.
No,
Hello world.
it wasn't. It wasn't. Yeah.
So,
So it was-
by default, it goes to Docker Hub.
Yeah. Exactly. It pulled it from the Docker Hub as a default image storage. And when the pull was complete, the Docker daemon created a new container from that image. And then it streamed the output to the Docker client, which sent it to the terminal. And then the process ended because it was not like a forever living process, but the process basically ended like as it was programmed in that way.
You can show the of the hello world. We have it open.
What you mean? Yeah, the repositories, sure. Yeah, so I can show you how the hello world looks inside. And we have, so each of the images is represented on the Docker Hub page, so you can easily find like information about all the images. So for example, this hello world, it tells you that it has some portations for Linux and for a Nano server, which is, I believe, Windows. Right? I think Nano server is Windows distribution, and that it can be like ported to multiple architectures and a lot of things basically that you need to know to be able to run it in your like specific information. So Docker Hub is a really good source of knowledge. And it also, what is important, it also contains a reference, usually to the repository, to the source code of the image. So now I moved to GitHub, and you can see that like inside the image there's a C program and whatever. Basically it does that, it runs a script in C that streams out basically this message, and then it ends. So this is like an easy way how can you, for example, run a program written in C easily on your computer. Docker will help you with this in a very elegant way.
Yeah, one thing is like, as you can see, the program is just intended to print something and then ends. And then we return to the shell terminal of the local computer. That means like the container is complete dead now, because there's nothing running. You just did something and that's it. Yeah. But for example, when I'm REST API, it keeps listening, so the Docker containers keeps running.
In comparison to HTTP server, which
exactly.
like is still listening and the process doesn't end. So that's why this. How can I get there? Oh.
Yeah, you want
to. Yeah, that's why this container ended right after streaming out the output. And for example, Node.js server container is still running when you run it, as you will see in a moment. So maybe we can move farther. How can I get to the presentation? Here? Oh,
this
one. So, yeah. Okay, so we just did this. And now, more like practical part, we will be talking something about building a Docker images. Basically, do you want to speak about the first one?
No, well.
No, okay, so I will.
Show it. Yeah, well, as I mentioned before, there's two ways basically to update a container and then afterwards build a new image. The first one is writing change into the Docker container that is running and then committing the change. Or we have a declarative way, which is Dockerfile, which is the best practice because the Dockerfile provides, we will see later, that it provides like a reproducible steps to build an image. So, for example, the ugly way to create a new image will be something like, I don't know, if we go to, we can use the same hello world. By default, if we run this, it will print the same thing, but the wrong command, you can like override the default like behavior of the container. So I can just put sh, which is the shell command. So you can see here, oops, yeah, I need to run this, sorry. This flag is basically to give me like a interactive shell to enter to the container. So I think it
maybe you can try Alpine Linux.
Yeah, I would try Alpine
It
better.
will be better.
Yeah.
Or some operating system image.
Yeah, Alpine is an image which is like a very lightweight Linux distribution. So well, as you can see, I just run this shell and I'm just inside the container in this moment. So if I want to update something, I don't know, write some new file, it's here, perfect. So I basically exit, and now I want to create a new image. So basically you will do, yeah, it's here. So basically the command is commit, the name of the container, which I forget, sorry. Oh, yeah, okay. The name was Thirsty Brown, I think. Okay.
It's auto-generated.
Yeah, the name of the containers are auto-generated. Okay, so first you need to put the name of your container that you just updated, which is Thirsty Brown in this example, and then you name a new container, which I name it like low Alpine. So basically this, what does is basically if I run the new container, which is low Alpine and shell inside of it, you can see the file is there. So this is a new complete image that you can spin new containers from it, basically. But this is ugly. This is not.
You
like,
have
there's no document
recorded to reproduce this.
Exactly. It's like the only way you could like share the knowledge how to build this image is basically writing a documentation, a text or something. But there's Dockerfile, which is basically doing the two things, like presenting the template of building a new image and basically documenting the thing. So that's the thing.
Yeah. So this was like the ugly way, but maybe sometimes you can find it useful. But I probably haven't ever done so. But it's good to know that it exists and it shows how all the things work. And yeah, and the second one is if you want to have the steps for creating the image like reproducible and persisted, then the best way to build your images is using Docker files, as you all probably know. And so now something about Docker files. It's a file that contains all the commands needed to assemble an image. It uses like built-in instructions, like some of the basic ones is the from instruction, which specifies the base image, which is like you usually don't start from scratch because you would have to do some like operating system configurations and stuff. So we usually start with like a proper base image. For example, if your goal is to create a node application, you start with some I don't know, Linux, for example, Linux-based image with installed node server and everything configured. So you can just copy your node application there and run node app.js and it's gonna work. So this like makes the base images make your life like easier, especially if you are a developer, not a system administrator. And copy instruction is serves for copying files or directories from like host machine to the container. Run instruction is for running whatever command by default in shell, and command is like the executable or what gets executed once the container is started. Yeah, and Dockerfile is the recommended way for building Docker images. So here's super simple Dockerfile. So in this sample, we are starting from Ubuntu version 18. We copy the content of current folder, so the folder where the Dockerfile is placed. to the folder called app in the container. They run make with the app folder parameter, and then they run some Python application that was probably copied there. But this is just this was just a sample. Let's write our own Dockerfile, and let's try to explain all the things more properly. So let me set it up. This.
Let me try to fix the writing. Yeah.
Okay. Okay, so need this. So imagine you have like simple server application in Node.js, which at this case it just does nothing and just exports or writes hello world on every request. And you want to, and it has, I don't know, some linter and tests, and you want to put it into Docker. So what you do, you have to create the Dockerfile at first. Probably the best place for the Docker files is in the project folder, but it can be placed anywhere. But if you place it to the project folder, you don't have so much work with referencing everything what you want to copy to the container. So you can just you don't have to write so much. The name Dockerfile. If you use exactly this name, Dockerfile, then if you will be then working with that, Docker will know by default that it should assume this file called Dockerfile. But you can also call it according to you, but then you have to specify some parameters that your Dockerfile has this and this name. So I would recommend to leave it called Dockerfile. Okay. So for example, for this Node application, we will need to start with some base image, and we can use, for example, base image already. This is the official base image for Node.js applications. It contains I believe Debian Stretch Linux distribution and Node.js version 12 installed. So this thing says that we are starting from that base image, and we call this build step. We call it base, or so far I can call it base, for example. And this will serve us later for targeting the specific build stages. We will see later. But we have operating system with Node installed in the container, nothing more. We need some probably folder where we want to put our application. So it's work there. Okay. I'm not used to keyboard.
Yeah, I have it.
This.
Yeah,
Okay.
sorry.
Here? Yeah, okay.
Because the keyword
Okay.
checks.
So what this thing does?
Yes.
Okay. Can I switch it to?
Anyone wants to switch?
Yeah, I want to switch. Oh, okay. Okay. So what this thing does? If there is no app folder in the root of the image, it will create it for you. And if it is, or once it is created, it will move you to that folder. So your root is now /app in the container. Then we need to copy something to the container, and the best idea is to start with probably with package.json because I know just when you want to install dependencies, you probably need package.json. generally a good idea is to start with like the dependencies, because one important thing in Docker files is that it really matters on the order of the instructions, and that's because when like something changes, and something like changes in your source code, for example, if you would put the copying of the source code as a first instruction into the Docker file, then once something would change in your source code, and you would copy the change to the container, everything like following would get rebuilded, because Docker files or Docker images include caching mechanism. So everything what is not like changed from previous building will stay cached, but whatever has changed from the previous building of the image will be like rebuilt again. So the best like solution is to start with things that don't change so often, and so that's not probably the source code, and the things that change very often, it's like the best way is to put them as far as possible, so ideally at the end. So right now we will install dependencies, so they have, let's say, smallest probability of the change. So let's copy the copy here, flash package star JSON to the app folder. So this thing takes this is the folder on the host, so where the Docker file is. So it takes these two package JSON files and it copies them to the container, to the app folder. Now we need run command, so we can. The run command is run in the container, and it runs npm install. So it uses the package JSON files to install all the dependencies, including the dev ones. So it will install for you into the container the dev dependencies and also the production dependencies at this moment. Then we can continue with copying the source code probably. So we can copy source. Oh. Shit.
Did you have any check?
No. I'm not completely used on this. Where's the
What
slash?
do you want?
Slash.
Slash here.
Yeah.
Here.
Ah, here. So we want to copy it to. Let me cheat sheet. Oh, I know, I got it. So we need the source code of our application. We need tests, because we want to run tests probably in the container, because if you run tests in the container, you have guaranteed that you run them like in the same environment as they will be like run in the production. Because if you would run your tests on your local machine, you would run them basically against the macOS. So there is like a possibility that there is some incompatibility in the environments between your like local environment and the one that is in container. So in this case, Debian stretch Linux. So this is copy tests to, I believe, app slash tests. Then is there anything else? Oh, int file. ESLint That's ESLint to no, to the root folder. ESLint RC, ESLint RC. I think it's okay.
Yes.
Oh, sorry. Yeah.
And isn't that each command is like one layer?
Yes.
Yeah.
Exactly.
Actually, I could do like copy dot dot, but then you like haven't under control what everything will be copied. So maybe for the readability and for like you having a control upon what will be in the container, it's probably I like it to specify exactly what I'm copying. Yeah, but you can do like this. This will also work, but it will copy like everything like from this to this.
So a lot of unnecessary things.
Probably, yeah, a lot of unnecessary things. But during this, it will. As you wanted to mention the Docker ignore?
The Docker ignore.
Yeah, exactly. But it will assume the Docker ignore file, so it won't copy things listed in Docker ignore file.
But I think it's still better to go in a defensive way than
Yeah.
rather specify what should
Yeah,
be copied.
I think this is like I like this way the most. So
Yeah, the Docker ignore file is quite important because it's, well, basically that your Git ignore, but also you need to like think of, for example, what things you don't want on your container. For example, one important thing to ignore for a container is the folder .git. You don't want your Git repository inside the container. That doesn't make sense. Or your README file or whatever that the code doesn't use. So that's quite important to like never forget the Docker ignore file, because this copy, imagine if you're doing copy ... it will check the ignore file and avoid those files. So that's quite important.
Okay. And now let's do also a production configuration image. So since last year you don't need like multiple Docker files for building multiple images. So you can reuse this mechanism. It's called multi-stage builds. So you can like reuse some of the build stages for some of the others. So for example, now I created, let's say, a development environment. So we have like in the image or in the container there will be included the dev dependencies. There will be tests. There will be linter. But for the production run, you don't need it. So let's also specify production build. Or build of the production image. So for this, you can use some more lightweight image. For example, slim version or alpine version. It basically contains only like things necessary for running of the common node applications. The dev version usually contains like much more stuff necessary usually for building. So this like dev version has around 70 megabytes, and this slim version has like, I don't know, 120, 150 megabytes. There's also possible to use the alpine version of the image, which is like even more lightweight, but it's maybe too much, as we got to know at the conference. They told us that the best practice nowadays is use the slim versions of the images because they are a little more robust than the alpine.
Yeah, the intention, the idea of doing this is because, for example, if we go to the Docker Hub page of Node, the first Node image that we're pulling from, Node column 12, it's based on Ubuntu, and it contains a lot of like a curl, many like stuff that is not useful for production builds. But we need it because sometimes we have in our Node module something that needs to be compiled during npm install, such as our bytecrypt. Probably all of you using bytecrypt to your stuff, and I don't know if you noticed when you're doing npm install, there's executed node zip, which is basically the C++ stuff that start compiling the library for you. So that's why you need the whole like utilities of, for example, Ubuntu provides. But then when you're ready to switch to production, a production build, a production image, you need to use, you can use a more lightweight base image, because everything has already been compiled in the step, the previous step. So in this step, you will see how Martin will basically copy everything from it, and yeah, it will at the end it will result in a lightweight image and not that heavy.
Yeah, I will do it in a moment.
Sure.
I need to create also dockerd in the new image and switch the context there. So it will have also, for example, /up work directory. Now we are there. And we need, since it's a production image, we need to take care of some security. As you maybe know, by default, the process in the container runs as root, or sudo with sudo permissions. And as we were talking about that, the Docker containers are sharing the host kernel system, the kernel of the host system. Running like everything here as with sudo permissions could be like potential security issue, because imagine that, for example, some of your like packages is nasty and wants to do like something nasty, and it can touch your let's say host operating system or whatever in the container. It can touch it in a nasty way. So we can like constrain this behavior, and for this it's a good practice to like specify a new user, to create a new user, and give only the proper permission to that user, and run the application just under that user that has constrained permission. And so so I think it's like payown. What's this? Node. So this is a Linux command telling that user with a name within a group node with a name node is an owner of the app directory. Mode 7.5.
Oh, one thing, the node user that Martin is using to set permissions for the app directory is already created on the base image. That's why you don't. There's no need to put like user create node, because if you go to the documentation of the node image, both the 12 or the 12 sleep both creates the node, the Linux node user. So that's why we're just using changing permissions, because it's already created.
Oh, okay. I can show you actually, probably. I can pull it, and then there is I can run Docker history on the pulled image, and we can see it. We can see how the image was created, so we will see that the user is really there, already created for us. So basically all the node images have pre-created a node user for these purposes. But once it gets downloaded, I can switch the context to the original node context. In the meantime, slow internet. Slow computer? Yeah, no, slow computer. So this is the basic security, what you should do probably every time you are planning to ship your images. That you shouldn't let it run with the sudo permission, but to create some user with constrained permission and run the application as that user. Yeah, now let me do the Docker history.
You don't see where you are right now.
Oh, sorry. So I have to, what I have to do?
Maybe the window smaller.
I don't want to make it smaller, but okay. Okay. Docker history and the name of the image. I download it. Okay. And I need some formatting. Docker history help. So I need the no trunk option.
You need to put the name page.
Yeah, sure. Oh, no, we have everything, but
Yeah.
I think in this, if you let me,
This is basically.
if you give me some time, I think I can find that the user is really created that.
Yeah. This is like.
I have it. Oh, here's the proof that the base image already includes the node user, so that's why you can do this. Okay. In case you wouldn't trust me.
Yeah, the Docker history command is like a useful way to see like what are the layers of that Docker image. In case you don't have the Docker file, it's kind of like it's not exactly a Docker file, but it gives you an idea what's going on or what's each layer made of, basically.
Okay. Now we can copy from the previous image. We can copy the package.json files, or I can do it also from the host, whatever. From def, I believe it's copied from def, and now the copy thing. Yeah. So it's like /up/ package whatever JSON, because JSON app package JSON and var, so to the app folder. Yeah. So why I'm doing this? I just need the package.json files again in the new image, because now since it's a production image, I want only install production dependencies and maybe do some other stuff like auditing of the packages or vulnerability scanning or whatever like necessary for the production build of the application. So I can now do run npm install how is it only production only like this. Yeah, so this, for example, this will install production dependencies only. As I said, you can add like other mechanisms to get your application production ready. And then we need to, then we can only copy like everything from the source image, from the def image, what was already created there. So we can copy from that def image yep. Which, yeah. So the idea of this is basically you use this def images for like testing and linting and stuff, and once everything is ready, so the source code in the def image is like ready and tested and stuff, you put it to the production image easily. Oh, and do I have some mistake there?
No.
We will see later.
You have any question or no?
Yeah, would that copy also the modules?
It will not because of the Docker ignore.
It also
Hopefully.
works between stages.
Yeah.
Mm-hmm.
Yeah. Basically.
Hopefully. If not, then we have a
Yeah,
bug
I
there.
think it should because the copy command is by default intended to copy from the host machine to the container. But in this case, the copy is copying from one stage of the same container to a different it's copying from depth, which is the stage defined before. So yeah, I think it should. Okay, but that's a good question. That's a
Yeah,
good
maybe
question.
we can.
But it should, because otherwise the copy command is kind of like is ignoring the Docker ignore only if you put the from. I don't know, that doesn't seem right. So but that's a good question.
Yeah, you can Google it, or we can get convinced later. But now we need some command to just run the application. Oh, shit. Oh, there it is.
Oh, sorry.
I have. I have an answer. So it's in source, yeah, source/app.js. So /app.js. Yeah, so this command tells that once the container is run, this process will be run, executed. It should
Yes,
assume,
Yeah, it should ignore the.
it should ignore
Yeah,
whatever is
when
listed
we
in Docker.
copy or
ignore.
not, it
Okay.
will- it will-
Yeah, it wouldn't make sense otherwise,
Yeah,
because
because-
everyone is doing it this way usually, so
Yeah.
it would be huge fuck up.
Yeah.
for, also for our applications.
That would break the copy command. It should. I think if they have intended to do that, they should have create a new command, not reuse the copy with a new flag. That doesn't make sense.
Mm-hmm. So I can try to build it to have our own image. So where are right now? Yeah, I have to go to So the
You can just stop.
is it working? Yeah, it is. Okay. And the command for building the image manually is docker build context, I believe.
No, you need to name it
Some talk. Yeah. But I believe it's like this it's like this. So this parameter is build context, and it tells that like everything what will be like because the build context before the image is built, basically the host machine sends the build context to the daemon. So in this case, it will send it like all this Olamundo API directory. And if you would be like touching from Dockerfile something that is not in build context, it would throw an error. So you have to specify the build context during or before building anything. So right now, I believe.
So yeah, you can see.
I triggered a build. Yeah.
Yeah.
And you can see that it's kind of slow, but with the new build kit, it's gonna be faster. New build kit was introduced this year, so we can look forward for faster builds. We have some error with some kind of platform portation of the package.
Oh, you can see that it ends with the first node column 12, or I mean like the depth stage, it ended. But now since we're for the production part, we need the node column 12 sleep. Since it's a new image, it's pulling from Docker Hub because it doesn't have it locally. So that's why it took a little bit longer. And it's almost there.
Mm-hmm. So now we can get convinced that we have the images built, and yeah, it's here, and it has 202 megabytes, and it contains right now production version of our Node application, and I can show you the things with the caching. So for example, if you if you change anything, for example, here somewhere at the end, for example, that I will copy only package JSON, not package log JSON, and if I will trigger build again, now watch carefully, it should cache, yeah, it has like cached everything until
Have you saved the file?
Oh, I haven't. Probably. You don't have how to save? Oh, it's Command S. Oh, it's
now building.
okay. So let me try again. It shouldn't be cached. Oh, yeah, no, thank you. It was not saved. So everything what like hasn't changed stays cached, and Docker is so clever that it will like rebuild only the part of the image that that has changed, or everything after the layer that has changed. So now you can see that until this line where I specified that I want to copy only package JSON, everything before was cached, and everything other is rebuilt. So this is a very good mechanism, like how to speed up your builds, for example, on CI or somewhere. And yeah, and here there is an error that I don't have package log JSON because I have omitted it. It might change. So that's probably everything about building the images.
Can I have
I
a
think,
question?
yeah, sure.
So what about this dev and prod slides, or how do you run them, or how do you find them?
If you want to, like by default, when I run this Docker build, whatever, and I don't specify this thing, target, it will go through all the Dockerfile until the end, and it will end up with like the last build stage. Yeah. But if you want to target only one of the stages, I can tell it that I want to build only the dev image, for example, this, I believe, and it will build for me only a dev image.
Yeah, we'll stop there.
Yeah, yes, I forgot to mention it. This is like a really important thing that I forgot to mention. Thanks for the question.
So, yeah,
Now it should make more sense why I did it this way.
yeah, you can see that now it's step 7 of 7 because it's only 7.
Yeah, only these 7 steps were done for me, and I think now we should have dev build of the application.
But the image name is the same.
Yes, but you can see that the name at the end it says workshop column latest. By default, if you don't specify the tag, it will always put latest. So that's another important thing that, for example, the best practice to put if we want to build exactly.
This is the best practice.
Exactly, we're
What
building
can I do?
development images, so let's tag it correctly. So it will be, you can name it whatever you want, 0.1 dev, whatever.
Yeah. So that's what the tags are good for the version specification and for the environment specification. So I think a good practice is to do it like, for example, this, that when you specify a version and then the environment, and you can work with this, for example, in some automated scripts on the CI or stuff. When you will be deciding what and where to deploy, you can use some regular expressions and work with these tags. But I didn't want to speak much about this session.
Deeper on the next. Or
Yeah,
about how helpful is this for development cycle.
Yeah, we wanted to next session we wanted to speak more about the local development with Docker and all of this stuff. But feel free to ask. Definitely, we can talk about it also today. because otherwise it's probably everything what we have prepared for this session. So now
Any question?
I would. Have you? Oh, I have a question actually. No, I just. No, I just wanted to ask if you have got known something new from Docker, or if it was everything like of course things for you.
For me, it was new.
At least was there at least one thing that you didn't know?
Yes.
Because this was like really super basic level. So
Multiple stages.
yeah, multiple
that's
stages
something
they are good. It's
2
called
years ago.
it's called multi-stage builds.
Yeah.
But it's since last summer, I believe, in Docker.
I think in 2017.
2017?
Yeah.
Okay, so then.
Yeah, because before this, you can imagine that you see repositories with Dockerfile dev, Dockerfile prod. You have multiple like Docker files because the builds changes between the environments. But with this, it's amazing. It's like basically one of the speaker of the conference said like free CI because you can have then a test stage and run test there and then even put like a npm audit and fail the build if there's some critical like you can imagine the possibilities and at the end it's like free CI on your Docker.
Yeah, so at this place you can, for example, run some audit for our packages, or maybe the better option is to have your image like scan. Once it's built, there are like services that can scan your images for the vulnerabilities, like once they are like built. So you can just pass the image to the service and it will tell you like everything about the image and if it has like vulnerabilities on the level of operating system, on the level of packages and stuff. For example, Snake can do it and stuff.
Yeah, one more question, very basic. I think so. If any command from there, like the CMD command fails, the build fails and stuff.
Yeah.
Well, the CMD
No,
never
not
fails because the
CMD.
CMD is very specific because that's the command that when you're doing Docker run, that's the command that you will execute. Everything else, for example, if a run fails or copy fails, some permission stuff, the build is.
Okay.
But then this is hard to fail during build time.
Okay,
Yeah.
This thing.
Right.
But if it fails, this can fail in a runtime.
You one more question. If you did mention that usually I see some entry point. What's the
Yeah.
difference between CMD and
I can show you.
That's quite interesting.
I think I know it probably. If I would write entry point, I don't know, it's like this. But yeah, it can be, for example, I don't know, this node. There is like multiple situations. If there is like only entry point present, so if it's like this, or whatever, I want to comment it out. I don't remember how. This one. Okay. Yeah, so if it's like this, it behaves like a command. Okay. If there is only a command, it behaves the same. But if there is like entry point and command, the entry point is like a prefix for the command.
It's like basically the
Because you can
the
have also
process.
multiple commands specified.
Yeah.
So your entry point can be like one prefix for multiple commands listed there, for example. So that's only what came to my mind right now from scratch, because otherwise.
Yeah, it's big. You
I'm
can
not
think
sure.
of entry point like a wrapper of your like executable. It's basically by default in this image is basically bash. So bash is calling node and node has some arguments. So now you're changing basically node. I don't want bash. I want just to run node directly, and then node has some arguments, which in this case would be the command itself.
Yeah.
So I think if we build this image and we try to remember that when I was committing doing the bad practice of updating the image, I was doing docker run on some container and then I overwrite the command. I think if we do the same with this new entry point, the sh, which I wanted to execute sh, will be an argument for node, and I will crash.
Oh, yeah,
That's one important thing, because the entry point is basically like listening for the comment. I mean, any comment that you want to put on the image.
So command you would specify on the run would would be like a CMD or entry point?
Will be
Uh,
CMD. It's basically command is basically replacing CMD, not entry point.
Maybe
Entry-
what
you-
I would say is that
No.
probably in Dockerfile, in this base image, there will be probably entry point with shell.
Yes, exactly.
Yeah.
Exactly.
Yeah.
Because-
So everything is like by default. There is an entry point with shell, probably somewhere in the base image Dockerfile, and it tells you that you should run everything in shell. But you can like override it like this. But you usually don't need it for this like
And as entry
simple
point,
application
does
builds.
it work only for this command, or if I would put entry point to right after the from, then the run command would also be called?
Oh, you mean like this?
Maybe it is
If you would.
preset, I'm just curious.
Oh, actually,
Yeah, it would be.
I think it doesn't matter.
Yeah, it doesn't matter.
It doesn't matter.
But the idea, I mean, that you can put CMD at the beginning. But remember that Docker works with layers. So these things that most likely will change in the future, you put it on the at the end because you want to get benefit of the catch system.
I think it can be
You
like
can
this.
do that, but it's most likely it will change in some point, and you don't want to because of changing some letter of there. I don't want to run npm install again. You know, that's the best practice. That's why it goes to the last because we don't want to catch that. Basically.
But I would say it's maybe because of like a readability that you usually specify something and then you are
Yeah,
like
also.
it's like a logical sequence that you run something at the end.
Yeah,
But from the technical standpoint, I think it doesn't matter almost.
One important thing, can you run Docker run help on the terminal?
Docker run help.
Yeah, exactly. Because as you can override command, you can also override entry point. You can override like environment variables. There's many things. We will show that in the next session. But for example, entry point can be also like I want to
Docker run help.
Yeah, that's the shell.
Sure. This dash help. Yeah, and you want to see.
Yeah,
what?
there are many things, and entry point should be there somewhere.
Ah, you mean the syntax? Oh,
Uh-huh.
yeah, most.
Entry point, yeah, is there.
Yeah.
So
Most
yeah.
of the things you can also pass as a parameters like to the commands directly. But it's like to keep your commands simple, it's good to persist everything into, for example, Docker files. You can put environment variables here as well. But the things can get more and more complicated.
Yeah,
probably.
you will see.
This demo is simple. So, no one had a question from remote people?
Yeah, back to the question I had before, I believe it doesn't work that way, from what I read from the internet.
What you mean?
That when you copy between stages, it doesn't take into account the Docker file.
I found in documentation that it does. I can send you a link.
I didn't find the documentation, I just found so many issues people had with this.
Okay.
Okay, so maybe,
I will send you.
I don't remember. I think we can try it. We
Yeah,
can try
yeah.
to run. We can try to run it. But it will be hard to see if the node files, node modules are from the host or not. But I have no.
Yeah, you can
reference.
remove the npm install only production, and then SSH log into that, and then check if there's node modules. It means like it got it from the previous.
Yeah, remove from that.
Yeah, exactly, remove that one.
And if it works, then
And now do Docker run or yeah, exactly like that.
Yeah, I'm just thinking if you're right, maybe we should also copy a Docker file, Docker ignore, to get it working properly. Oh.
If it doesn't work, it's basically
Yeah, so
no,
we
we
need
build
to
a new
build
one.
it.
And
So
without
Someone wrote that in between the stages
now
it doesn't work.
Okay, that sucks.
That it work only when doing normal copy, but not between stages. But it's 2 years old.
So we have
The same age of the new return.
So if I do Docker run
Workshop.
workshop, and shell.
Uh-huh.
I have a
Now
shell. ls. Oh, we
Yes,
have
it's
more
there,
modules.
So, yeah, yeah.
So it's bad.
Yeah, you copy everything.
And yeah, it's not a bug, it's a feature.
Yeah, it's,
Oh, but we have a bug in our Dockerfile then.
yeah. one way to avoid
So-
this is to like.
What if we copy also Docker ignore?
You can run npm rule on the dev.
No. What? Yeah. Well, that will work.
Or you can remove the files manually.
No, or we can change the order. Start the base image will be the production one. We only install production, and then the dev one we just npm install only dev, and
you
we
can
install the remaining stuff.
switch the stages.
That could be a solution.
Once you have the problem with
You are a wise man.
With
with beacon, for example. As you said before, that you need the bigger image to install.
yes, it's it. No, but that's.
Oh yeah.
No, that the bigger image is the. I mean, like the image of Ubuntu, for it in this case, that contains the utilities, for example, makefile and stuff to build some binary. But in this case, if we switch, we only install. We start with the production-based image, and then on the dev image, if we want to go there, we install whatever is behind.
So we will run the npm install on the image again.
Yeah, but only development because we already have production, and then we have everything.
Okay, so we should
That could be.
we should correct the workshop materials. Thanks for this. Actually, all of us are learning something.
Well, this directory that where all this code is basically representing a Git repository that we will share after the workshop. Or
After we will correct
can put
this.
it now.
Oh yeah, we'll do the correction.
Exactly. Yeah.
Okay.
Okay,
Thank you
guys.
very much.
Don't forget to save the recording.
Yes.
I can do it.